Okay, good morning. Metal carbonyls. Complex of transition metal with carbon monoxide or carbonyl group are called metal carbonyls. For example, nickel tetracarbonyl, fresh pentacarbonyl, chromium hexacarbonyl, the Lewis acid, okay, it's the carbon monoxide. Carbon monoxides have the lone pair of electrons. It also acts as a Lewis base and also it accepts electron pairs by the back bonding. Carbon monoxide acts as Lewis base, Lewis ligand, because it donates a lone pair of electrons from the carbon atom to the metal center. The bonding in carbon monoxide is represented as where the carbon possesses a lone pair that is donated to the metal atom during complex formation. In addition, carbon monoxide can accept electron density from the metal through pi back bonding, which strengthens the metal carbon bond. Bonding in metal carbonyls. Oxygen, this is the carbon. This is the metal carbonyl molecular orbital structure. Carbon 1 is to 2 is to 2p2. Oxygen 1 is to 2 is to 2p4. Molecular orbital configuration. Sigma 1 is bonding, sigma 1 is anti-bonding, sigma 2 is bonding, sigma 2 is anti-bonding, pi bonding to py2, pi bonding to pz2, sigma bonding to px2, pi anti-bonding to py0, and pi anti-bonding to pyz0, sigma anti-bonding to px0. Bonding in metal carbonyls can also be explained in the following two steps. Carbon monoxide metal forming sigma dative bond. The first bond is formed by donating of electron pair from carbon monoxide to metal. This bond is formed by the linear overlap between field sigma bonding to px molecular orbital and backend hybrid orbitals forming carbon monoxide metal forming sigma dative bond. Metal carbonyl bondings. This is the vacant hybrid orbital. Field sigma 2px molecular orbital of carbon monoxide and carbon monoxide metal sigma dative bond. Metal carbon monoxide pi dative bond. The sigma dative bond thus form are weaker. To a second bond is the formed by donation of electron pair from metal to carbon monoxide. This bond is formed by the lateral overlap between filled d orbitals of metal and back-end pi antibonding to py or pi antibonding to pz molecular orbital of carbonyl group, forming metal carbon monoxide pi additive bond. This bond is usually called back bond. This backbone transfer excess electron density from metal to carbon monoxide. The metal fill metal d orbitals and back end pi antibonding 2 pi I or 2pz molecular orbital, metal carbon oxide pi additive bond, backbone. Thus, the total bonding in metal carbonyls can be represented. Dative sigma bond, dative pi bond, carbon monoxide. Structure of metal carbonyls, for example, nickel tetracarbonyls, nickel 3D8 4s2 in the ground state, in the excited state, is the pairing state, and nickel atom in nickel tetracarbonyl. Tetrahedral structure. Structure tetrahedral of nickel tetracarbonyl. Ferrous pentacarbonyl, ground state, in the pairing state. DsP3, trigonal bipyramidal. Hexacarbonyl, chromium hexacarbonyl, D2sp3, octahedral. What is the back bonding? Explain this bonding in metal carbonyls. What is the back bonding? Explain this bonding in nickel tetracarbonyl. Explain the nature of bonding in metal carbonyls.